Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue what we studied about the covalent bond. Today we're going to focus on the naming of covalent compounds or molecules. Our objectives for today are to use the rules to name binary molecular compounds and to name the acidic compounds. Take a look at this periodic table and recall that the covalent compound or the covalent bond, it occurs between two nonmetals. As you can see here, the green ones are the nonmetals. So whenever there is a bond between, for example, the carbon and the oxygen, it's going to be a covalent bond between them. If you haven't watched the previous video, I recommend you guys to watch the video before we continue naming the compounds. Let's take a look at these molecules. For example, if we have H2O, hydrogen and oxygen, both of them are nonmetals, as you can see here, and the molecule is bonded, or the atoms are bonded together covalently, as well as the methane, nitrous oxide, ozone, and the carbon dioxide. But today we're going to focus on naming, or the proper way of naming these compounds. So let's check the rules of naming binary covalent compounds or covalent molecules. And when we say binary, it means that they consist of two elements, regardless of how many atoms are in this molecule. So maybe it's between hydrogen and oxygen, or between nitrogen and oxygen. See, here we have three atoms, two hydrogen and one oxygen. But the water, or H2O, it consists only of two elements, the hydrogen and the oxygen. So this is what is meant by binary covalent molecules. The first rule, it says that the first element in the compound is always named first. There is no change for this name for the first element. But the second element in the compound is named using its root and adding the suffix IDE. You will understand better when we have some examples. The third, the prefixes are used to indicate the number of the atoms. With an exception, the first element never use the prefix mono. All right, let's check this table now. When we have only one atom, we give it the prefix mono. Two atoms, di. 3, tri. 4, tetra. 5, penta. 6 is hexa. 7, hepta. 8, octa. 9, nona. And 10 is deca. It's very, very important to memorize these prefixes in order to name any covalent compound or the binary covalent molecule. So let's check those examples here. A, if we have this compound, covalent compound, which is Ni3. So according to the rules, the first element, nitrogen, it has only one atom, nitrogen. And according to the exception here, the first element never used the prefix mono. So we don't use the prefix mono for it. And it's the first element. That means we name it the first and there is no change on it. So we're going to start with nitrogen. And the second atom here is iodine. What we need to do is, for the second element, is named using its root, which is io or iod, and adding the suffix IDE. So it's going to be iodide. So here we have iodide. All right, but we have three atoms of the iodine in this compound. So we're going to use, before it, we're going to use the tri. So this compound will be nitrogen triiodide. Let's have another example, which is B. And B is CS2. Again, the first element, we will not change the atom's name. It's going to be carbon. And we do not write mono because it's atom number 1 or the first element. The second element is the sulfur, and we use the root of the sulfur, which is sulf. Adding IDE, it's going to be sulfide. And because we have 2 atoms of the sulfur, it's going to be disulfide. So the compound is carbon disulfide. For example, in E, we have oxygen and 2 fluorine atoms, so it's going to be OF2 is going to be oxygen difluoride. These are the rules of naming the binary compound, as you can see here. I want you guys to pause the video and try to name the compound C, which is N2O4. All right. The second part of the lesson, which is also naming a covalent compound, is naming the acids. And for the acids, we have 2 types of acids. We have also the binary acids, and as you can see, it contains only hydrogen, always, and 1 other element. Usually it's a nonmetal. And usually it's a halogen, which is fluorine, chlorine, bromine, iodine. The exception is HCN because it has also H and it has 2 other atoms, the carbon and the nitrogen. The rules of naming the binary acids, the first word has the prefix hydro. So always we start with the hydro because it's an acid. Then the root of the second element plus the prefix IC in this case. In the binary compounds, which are not binary acids, we use IDE for the second element. But for the binary acids now, we use the prefix IC. The second word is always acid. So basically the binary acids, it consists of 2 words. The first word is hydro, and then the root of the second element plus the prefix IC, and then we add the word acid. So the rule is for the binary acid, hydro, the root of the second element, IC, and then acid. Let's have an example. For example, the HF. So always we're going to start with hydro. And then the root of the second element, which is fluorine. So it's going to be fluor. And then IC, the second word is going to be acid. So here is the hydrofluoric acid, and this is 1 word, hydrofluoric. We start always with hydro, the root of the element, the second element, adding IC as a prefix, and then the second word should be acid. Another example, which is the HCl, is going to be hydrochloric acid. I want you guys to try for the HBr and the HI. All right. The second type of the acids are called the oxyacids. Oxyacid, from its name, it means it has oxygen in it as well as the hydrogen. So the general formula for the oxyacid is going to be H, and then the central atom, which is usually non-metal, and then oxygen. And the only difference between those acids is the non-metal or the central atom, also the number of hydrogen atoms and the number of oxygen atoms. We call this acid oxyacid, and the difference between the oxyacid and the binary acid is that the binary acid consists only of hydrogen and another element. But the oxyacid, it consists of hydrogen, central atom, which is a nonmetal, and oxygen. Some examples about the oxyacids is HNO2, HNO3, H2SO3, H2SO4, etc. All those acids are oxyacids. The rules of naming oxyacid is summarized in this table. Here, we're going to start with this one and this one. For example, for HNO2, as you can see here, it has less oxygen. So here is minus oxygen than HNO3. When the oxyacid has lower number of oxygen, we're going to start with OUS, or we add the prefix OUS for the acid. So for this oxyacid, which consists of the central atom nitrogen, is going to be nitrous acid. We didn't add hydro, we didn't add IC, we add OUS for the central atom, which is nitro. So nitro acid. Now here, for the HNO3, we have more oxygens than HNO2. We have one more oxygen. That means the oxidation number, which you will study later, for the nitrogen here is higher than the oxidation number of nitrogen in this compound. So for the HNO3, it's going to be nitric acid, IC, when it has higher oxygen. Both of them, they have the same root of the element because both of them, they consist of nitrogen as a central atom. We didn't add hydro because it's not binary acid, it's an oxyacid. And we add OUS for the lower oxygen, and we add IC for the higher oxygen, this one. And followed up with the word acid. Let's have another example. H2SO3 and H2SO4. So H2SO3 here, it has lower oxygen, and here it has higher oxygen. So basically this one is going to contain OUS, and this one the IC. So for the H2SO4, SO3, it's going to be the sulfurous acid. This is you. Sulfurous acid, because it has lower oxygen. And the higher oxygen here, we have the sulfuric acid. All right. For the H2CO3, we don't have H2CO2 or H2CO4. So it's going to be, this is the highest oxygen that we have. So it's going to be carbonic acid. Same thing for H3PO4. We don't have H3PO2 or 3 or 5. So it's only one acid. So this one is going to be, because the central atom is phosphorus, so it's going to be phosphoric acid. With IC. Now here is an exception, because as you can see here, we have this HClO2, we have the HClO3, and we have lower than O2, which is only one oxygen, and we have higher than O3, which is HClO4. So basically here, we started with the higher oxygen, IC, just like the sulfuric and the nitric acid, the lower oxygen, OUS, which is the nitrous and the sulfurous acids. But when we have higher oxygen, so when we add more oxygen to the acid, this one, this formula, it has more oxygen. So we're going to use per. And then the prefix or the root of the central atom using IC as a prefix and then acid. So basically this one is going to be per chloric acid. Why we use per? Because it's higher than the highest oxygen. Now, when we have lower oxygen than the lowest oxygen, as you can see here, HClO, so here minus oxygen, so we're going to add hypo instead of per. So the lower than the nitrous acid, we're going to use hypochlorous acid. This one is going to be hypochlorous acid. So now we have two rules for the oxyacids. The higher oxygen is IC followed by the acid. The lower oxygen is going to be OUS followed by the acid. If we don't have high oxygen and low oxygen, it's going to be IC with the acid, just like the carbonic and the phosphoric acids. If we have higher oxygen than the IC, we're going to use the perchloric IC acid. If we have lower oxygen than the OUS, then we're going to use hypo-OUS acid, just like the hypochlorous acid and the perchloric acid. Let's check how the questions in the exam come. What is the chemical formula for dinitrogen hexoxide? I want you guys to take 2 minutes, pause the video, and try to answer this question. All right. So the chemical formula, you are given the compound's name, and we need to write the chemical formula for it. As you can see, this is the atom number 1, which is here, there is I, it's a mistake. So it's dinitrogen, and we didn't change the first element, so it's going to be N. And because it's dinitrogen, di refers to number 2, so it's going to be N2. Hexoxide, hexa, it comes from the letter or the number 6, and oxide, it came from oxygen, so it's going to be O6. Let's double check. For number 6, we have the hexa. And why did we write here in the name, we write it hexoxide? Basically here it should be hexa oxide. But the rule says, this is also an exception with the oxide, because we have A here and O here, so we're going to remove the A. Another exception, if we have, for example, monoxide, we don't write double O. We write only one O for the oxygen, and we remove the O for the mono. All right, so the chemical formula for the dinitrogen hexoxide is going to be N2O6. What is the name of the aqueous solution of H2SO4? Don't forget that we have H2SO3. We need to memorize these two formulas. And we have H2SO4. Because this one has higher oxygen, so we're going to use the IC. And because it's an oxyacid, we don't start with the hydro. So it's going to be sulfuric acid. All right. Explain why HCl is hydrochloric acid while HClO3 is chloric acid. See the difference between them? HCl is a hydrochloric acid, and the HClO3 is the chloric acid. Of course, because this one is a binary acid, And with the binary acid, we only use hydro. Then the root of the second atom added to IC. And then the second word is going to be acid. Whereas the chloric acid, because this one is the higher oxygen, it's not perchloric acid, it's only the chloric acid. Perchloric acid is going to be HClO4. And the one below, or when we remove one oxygen, is going to be HClO2. This is the chlorous acid. And when we have the HClO, this is the hypochlorous acid. All right. Question number 4. What is the correct name of HBr in an aqueous solution? A lot of students, they make a mistake about this compound or those compounds because they think it's a binary molecular compound. They forget that it's in its aqueous solution is going to be an acid, and this acid is a binary acid. So some of the students, when they do the mistake, they write it mono hydrogen mono bromide, and this is incorrect. Incorrect for two reasons. This is not only a binary molecule, it's a binary acid. And the other mistake is that for the first element, we never use the word mono. As you can see here in the rules again, prefixes are used to indicate the number of the atoms. With an exception, the first element never used the prefix mono. So even if it was, for example, here, nitrogen triiodide, we didn't write mononitrogen triiodide because we never used the word mono for the first element. So it's wrong because of two things. Mono, we cannot start with the word mono or the prefix mono. And also, this is not a binary molecule. This is a binary acid. So the correct name for the binary acid, we always start with hydro. And then bromic with IC and then acid. Two words, hydrobromic acid. Number 3, the correct molecular compound name for H2O2 is hydrogen oxide. No, because here we have two hydrogens, so it's going to be dihydrogen. And we have two oxygens, so it's going to be dioxide. So dihydrogen, dioxide, B is the correct answer. For C, dihydrogen monoxide, no, it's not correct because dihydrogen monoxide is going to be it's going to be H2O, which is water, dihydrogen monoxide. And hydrogen dioxide, no, it's not correct because we have two hydrogen and it should be dihydrogen dioxide. I hope you guys learned something new today. If you have any questions, just write in the comments. Have a nice day. Bye-bye.